So what we're going to work on today is we are on 8B.2. Okay, we're on 8B.2. And what we're going to be working on today is we are going to simplify logarithmic expressions. Okay, simplify logarithmic expressions. Essentially, all we're doing today is not reducing, but we're just simplifying. That's all we're going to be working on today. Just simplifying. Okay, we're just simplifying. So, what I want you to make sure you remember, out of 17. Okay? Remember the conversion between log base b of a equals e. Okay, that's written in log form. And that is equivalent to an exponential form, b to the e equals a. Okay, this is a huge key that you have to have memorized. Okay, you're going to have that memorized because we're going to use that a lot. Okay, a lot. So if your instructions are to simplify, there are a couple of steps to simplifying. Okay, there are a couple of steps to simplifying. Step 1 is to set expression equal to x. Okay, so we're always going to start with set the expression equal to x. Step 2 is to write in exponential form. Write in exponential form. Step 3 is to rewrite each side of the equation. Rewrite each side of the equation to have the same base. Step 4 is drop the bases. Is anyone noticing that this is sounding familiar?
Yeah.
This is sounding a lot like what we just did in our last unit. Okay, and finally step 5 is to solve for x. So essentially what we're going to be doing today is just getting these log equations into a form that we already know how to simplify. Okay, which is what we did in our last unit in 8A. Okay, now there's a big key here. Okay, when you are simplifying, I want you to make yourself a note. You need a left and right side of each problem. Okay, you will need a left and right side of each problem. So keep that in mind. So for number 1, again, I just want you to simplify. I want you to simplify log base 3 of 81. Simplify log base 3 of 81. So the first thing you want to do is we want to set this expression equal to x. Now usually people will just put equals x on the right side. I'm going to tell you that it's actually a little bit easier if you put x equals on the left side. Doesn't matter, it's going to end up being the same. But when you read these to put them into exponential form, it's a little bit easier to read them from left to right, just like reading a book. Okay, so here, how do I write this in exponential form? Say it with me. X is the exponent on 3 that makes 81. So x is the exponent on 3 that equals 81. Okay, so you just have to get used to that. Then we're going to get the same base. So these both can be a base of 3. So 3 to the x equals 3 to what power equals 81? 3 to the 4th. Now that you have the same base, you can drop the bases and solve. X equals 4. that's your answer. Now, eventually, you will not have to do all of these steps. You'll just be able to figure out, okay, 3 to what power equals 81? You'll get 4 really quickly. Okay, starting tomorrow, we're going to do something called log facts. They're basically just like math facts. Okay, like when you were in elementary school, you did multiplication facts or addition facts or something. We're going to start doing log facts. Okay, because these are going to be something that you are going to need to get super good and super well practiced at. So we are going to do log facts. They're just like math facts. Okay, Haley, did you have a question? No. Okay, let's try another one. Same thing. I still want you to be, oops, sorry, sample 2. I still want you to be simplifying. Simplify log base 3 of 1 over 27. Log base 3 of 1 over 27. Okay, first thing you want to do is set the expression equal to x. So make it an x equals. Then rewrite in exponential form. So how would I write this in exponential form? 3 to the x power. So don't say 3x because it's 3 to the x power. Okay, if you say 3x, that implies that it's all on the same level, and they're not. Okay, so 3 to the x power equals 1 over 27. You do not have to put it in parentheses. If you want to, it's going to be the same thing. Okay, so I'm going to get these in the same base. So my first step to getting these in the same base is 3 to the x equals, if I need to move this up, what exponent moves it up? A negative, right. So 27 to the negative 1. Then can I write both of these as a base 3? Yes, 3 to the x equals, 3 to what power equals 27? 3 to the third, so negative 1 times 3. Okay, if you multiply those together, we get 3 to the x equals 3 to the negative 3. Drop your bases. Therefore, x is negative 3. Okay, so we're just simplifying. Yes, ma'am?
Is it okay if we just go straight to the 3 to the negative 3?
If you could tell, yes, that's fine. If you know how to get your exponents, but if you need to show the steps and take it one by one, that's fine. Okay, a lot of you guys made lots of silly mistakes on this, on your test. So take the time if you need to show the steps until you're getting really good at these. Okay, I don't want you messing up just because you're going too fast and you're trying to skip steps. Okay, show as much work as you need to. Trust me, it will help your grade. Okay, try another one. For number 3, again, we're still going to be simplifying. Okay, for number 3, I'd like you to simplify log base 4 of 16 root 4. Log base 4 of 16 root 4. Notice when I say base, this is going, it's called subscript. Okay, so it moves like down half a space. Same steps, so first thing you want to do is put in an x equals. Then if we rewrite this in exponential form, x is the exponent on 4, so 4 to the x power. That makes 16 root 4. X is the exponent on 4. That makes 16 root 4. Next, I want to split this up. So I want to get roots of 4. So 4 to the x equals 4 to what power equals 16?
Second.
Squared times 4 to what power equals root 4? 1/2. Now, a lot of you guys messed this up on your test, okay? If you are putting these together, do they add or do they multiply? They add, okay? If you multiply these together, you would just get 4 to the first. Is 4 to the first equal to 16 root 4? Absolutely not. Okay, this doesn't make any sense. So think about it here. When we add these together, we get 4 to the 2.5. But remember, I don't want to leave things this way. I need to rewrite them in improper fractions. So when you drop the bases, we get x equals 2.5. To convert that, which a lot of people also had issues with, you take the big number, multiply by the bottom, add the top. So x is 5 over 2. X is 5 over 2. Anyone have a question on how I did that? Please, please, please be really clear on when you multiply things, when you add them. Also, if you wanted to, technically you could drop these both to be base 2, but you do not have to. Okay, they both can be base 4. If you drop them to base 2, things would end up reducing at the end, and that would be fine. Okay, and you'd still get the same answer. But you do not have to drop those to be the lowest base, just the one that's the lowest in common. Okay, let's try log base root 2 of 1 over 16. Log base root 2 of 1 over 16. Log base root 2, 1 over 16. Start by introducing your x equals. Rewrite this. So x is the exponent on root 2. Root 2 to the x power equals 1 over 16. Now, this one we're going to have to change both roots, or both bases, excuse me. What do both of these bases have in common? A 2. So 2 to what power equals root x? 1/2, right, excuse me, root 2. So 2 to the 1/2 x power, those multiply together, equals 2 to what power equals 1 over 16? -4. Think of it as 16 is equal to 2 to the 4th. If you move it up, if it moves to the other side of the fraction bar, you make it negative. So 2 to the -4. From there, we can drop our bases. That gives you 1/2 x equals -4. How do I get rid of that? How do I get rid of this fraction? Multiply it by 2. So multiply both sides by 2. X equals -8. And that is simplified. Okay, -8. Do we have any questions so far? So this isn't something that I would say is particularly difficult. It's just absolutely brand new. So there's lots of room for errors here. Okay, so if you can get this pattern down, you should be fine. Okay, but I want to make sure that you guys are really good at simplifying and doing these real basic ones before we move on to ones that are a lot more complicated. Okay, log base 2 of the cube root of 1/4. Log base 2 of the cube root of 1/4. This one's tricky. There are 10. Still gonna do the same thing. We're still gonna introduce an x equals. So x is the exponent on 2, so 2 to the x. That equals, how do I rewrite this?
2 to the -2.
Well, let's think about this, okay? First up, how would I write the 1/4? What is the power on 1/4 right here? Power of 1, handle of 3. So this is really 1/4 to the 1/3 power. Do we agree? Okay, power of 1, handle of 3. Do not multiply these together. Okay, they're not supposed to be multiplied. Then from here, we need to get a same base. So you know your base needs to be 2, so 2 to the x equals, 2 to what power equals 1/4? 2 to the -2 multiplied by 1/3. So if you multiply these together, we get 2 to the x equals 2 to the -2/3. Okay, when you drop your bases, x is -2/3. So there will be some that are a little more complicated like that. Okay, but you should be good with your exponents. We've done all of this type of thing before. Okay, you just haven't seen the word log. But you should be good with simplifying exponents. We've done kind of a lot of that. Okay, try another one. Log base 2, or excuse me, log base 1/2, my bad. Log base 1/2 of 16. Log base 1/2 of 16. You try this one on your own. Okay, did we all get 1/2 to the x equals 16? Okay, from here, what is the common base? 2. So 2 to what power equals 1/2? The -1, so 2 to the -x equals 2 to what power equals 16? 2 to the 4th. Okay, again, if you have trouble with your powers, they're all posted on the chart. Okay, it's over in the corner now, but they're all posted on that chart. Most of the ones that you will need. Then, drop your bases. It gives you negative x equals 4. Divide both sides by negative. X is a negative 4. Anybody have questions? Okay, next thing we're going to go over